In this section, we're going to move on to our next big data structure. And this next one is something that I'm kind of excited about, I guess is the best word for it, because this next topic is something that is actually kind of useful to know about for front-end and back-end development. So we're going to be talking about trees. And you will not believe how often trees come up in software engineering. So it's something that you'll see very frequently, even with business type, boring applications, you will see uses of trees. And I personally have worked at several jobs where I had to use a tree to achieve some given task. It was just the best thing to use. So in this video, in the next couple of videos, we're going to get a better idea of what trees are. We're going to learn about some of the different parts of a tree, like what they're called and whatnot. And we'll also get a good idea of what we might sometimes use them for. Now, I want to be really clear right now, there are several different types of trees out there. We're going to first start off by looking at the most basic type of tree, and then we'll start to specialize and look at some of the different types of trees that exist. So first, the most basic one, and then we'll start to talk about some of their more specialized uses. So anyways, let's get to it. Let's look at a diagram. So here's a diagram of a tree. We're going to see many diagrams that look exactly like this right here. And I just wanted to show you the structure of it one time without any words or extra arrows around it. So let's first start off by trying to label some of the different parts of this tree. Firstly, every box that you see on here can be referred to as a node, just like when we were working on linked lists previously a little bit ago. An individual node, so like node 20 up here at the top, holds some amount of data, so just like with the linked list, and then it will also hold a reference to all of its children. A child is any node that is directly underneath a given node. So in this diagram right here, we would say that elements 0, 40, and -15 are all children of node 20 up here at the top. Likewise, all nodes 0, 40, and 15 can refer to node 20 as being their parent. So we often say that we have a parent-child relationship between different nodes on a tree. Now looking at this little node diagram right here, you will notice that it looks awfully similar to a linked list. So we've got some amount of data that we might want to maintain at some individual node. Now this data can be absolutely anything. In this diagram, I reflected it as being numbers, but it could be a string, an array, an object, whatever we need it to be. And there's many different situations where in a practical use of a tree, we would stick different values in there. Let's move on. Okay, like we just said, 20 would be the parent of 0, 40, and -15. And 0, 40, -15 could refer to 20 as their parent. We also refer to the relationship between nodes at a given level as being siblings. So in this example, nodes 12 and -2 could be referred to as siblings. -2 and 1 would also be siblings. Now, 1 and -2, notice how 1 has a parent of 0 and -2 has a parent of -15. They are at the same level, but we wouldn't necessarily refer to them as being siblings because they do not share a single common parent. 1 has a parent of 0 and -2 has a parent of -15. Now when you start to see questions about tree data structures, one of the most common things that you're going to be asked, or probably the most common operation that you're going to have to learn how to do, is tree traversal. So whenever you hear the word tree traversal, we are talking about iterating through all the different elements within a tree, which is essentially what we just spent all that time with around linked lists. Like everything about linked lists was really about iterating through every element in it in some fashion. And so with trees, it's very much a similar thing. We really care about our ability to iterate through all the different elements within a tree. Now, there are two big ways that we are going to learn about how to iterate through a tree. And when I say two big ways, I'm talking about the order in which elements we iterate through the tree. Because when you look at this, you can't necessarily immediately point at some distinct order in which you would start to list all these elements out. If I told you to count through all the elements here or to just read them aloud, I think half the people watching this video would say, okay, 20, 0, 40, 15, and then maybe the other half would say something like 20, 0, 12, -2, 41. In other words, there's not really a distinct order of elements here that you and I could necessarily agree on to visit in this tree. So when we start talking about tree traversal, there are two distinct ways in which we order the elements and iterate through those elements. So let's very briefly talk about both those ways, because we are going to iterate this and we're going to implement this, and we're going to spend a lot of time on tree traversal. So right now we're just going to do a quick taste. The first one is breadth first traversal. So with breadth first traversal, we iterate at each level of the tree from left to right. So we would start at the very top, or the root of the tree. We would visit this node. We would then go down to the next node, and we would start at here. So we'd start at this level, and then we would work our way from left to right. So we would go 0, 40, negative 15. We would then go down to the next level, and we would go from left to right again. 12, negative 2, 1, negative 2. Now notice that even though 12, negative 2, and 1 do not have a common parent with negative 2, that doesn't matter. We're still going from left to right here. So we go 12, negative 2, 1, negative 2. In other words, start at the top level, go from left to right, go to the next level, go from left to right. Again, this is breadth first traversal, and we will learn how to implement this type of traversal very shortly. Now, the next one that we're going to talk about is much more challenging for me to show you in diagram format. This is really something that's easier to kind of like point at and show you the order, but it's one of those things where you kind of have to understand it yourself or come to terms with it on yourself. So I'll do my best to describe it, but we'll see how good it goes. So with depth first traversal, we start at the very top of the tree, and then we go down the very left-hand side as far as we can go. And then as soon as we hit the bottom, we go back up to the closest parent and then go back down again. Now with words, that doesn't really make a lot of sense, so let's try to look through the diagram here. So with depth first traversal, we would start at 20. We would then go down to 0 and then negative 12. So we went from the very top to the very bottom. We spanned the depth of the tree, so to speak. After hitting 12, we then go back up to 0, and then we go down to negative 2. So we're still trying to get down to the bottom of the tree as fast as we can. We then go back up to 0, and then down to 1. After we visited all the children of 0, we then go back up. We see that 40 has been unvisited, so we go down to 40. We then go back up to 20, and then go to negative 15, and then down to negative 2. So if I were to write out the order of numbers here, it would look a little bit something like this on the right-hand side. But in general, you can kind of imagine if I had a marker and I can draw a shape that goes like all the way down, and then back up and down, and then back up and down, and then go all the way back up and down, back up and down. So essentially with depth first traversal, we try to get to the bottom of the tree as quickly as possible. Okay, so again, that's the two approaches to traversal. We are going to implement them both. So even if my very short kind of terse descriptions right now aren't clear, that's totally okay, because we are going to really learn in great detail how to implement both these. So let's take a quick break right now. We're going to continue in the next video, and we're going to start writing some code around trees. So I'll see you in just a minute.